Greetings to all my dear students. Last day, we started with lesson 2 in chemistry, acids, bases and salts. We discussed the physical properties of acids, bases and salts and also have discussed its behavior with indicators, the color change and the change with the olfactory indicators also. Today, we will study about the chemical properties of acids. When we discuss the chemical properties of acids, we discuss the behavior of acids in metals and various types of compounds. Acid reacts with metal to give salt and release hydrogen gas. Different metals have different rates of reaction with dilute acids. Sodium, potassium, lithium react explosively with dilute acids. Copper, silver, gold, on the other hand, do not react with dilute acid. As a result, no product has been formed. When an acid reacts with a metal to form a salt and hydrogen gas, depending upon the acid, salts change. Hydrochloric acids give chloride salts. Sulfuric acid, on the other hand, gives sulfate salts. We will discuss the two examples here. The metal zinc, when reacts with dilute hydrochloric acid, gives zinc chloride along with release of hydrogen gas. The word equation, when transformed as formula equation, it will be as Zn plus HCl gives ZnCl2 plus H2. Since chlorine and hydrogen atoms are more in the product side, to balance the formula equation, which is unbalanced or skeletal here, we do specify the coefficient 2. After this multiplication, we have equal number of atoms of each element to reactant product side respectively. Second example is of magnesium metal, which reacts with sulfuric acid and gives sulfate, magnesium sulfate salt along with release of hydrogen gas. The formula equation for this changes Mg plus H2SO4 gives MgSO4 plus H2. The release of hydrogen gas, which is colorless and odorless, can be identified by simple experiment. The gas, when collected in the test tube, gives pop sound when a lighted splinter or burning splinter brought near to its mouth. The same can be seen with this lab demonstration or adjustment. We can see with the help of a stand, a test tube has been fixed which has zinc granules and dilute sulfuric acid. The mouth of the test tube has been closed with the help of cork to which a delivery tube is been attached. The end of the delivery tube is in a beaker containing soap solution. When we observe the formation of gas bubbles on the surface of zinc granules, we see bubbles are formed in the soap solution as gas transfers through delivery tube. This results in formation of soap bubbles filled with hydrogen gas. When burn candle being brought near to the gas bubbles or soap bubbles, the gas comes as with a pop sound. Metals then We can say react with hydrochloric acid to give metal chlorides and evolve hydrogen gas. Metals, when react with sulfuric acid, then give metal sulfates and hydrogen gas. This is the reason only curd and other sour food stuffs such as vinegar, lemon juice, or orange juice should not be kept in metal vessels. Even in laboratory, acids are not stored in metal containers but either in glass or plastic containers. Second, chemical properties of acids include neutralization reactions. The reaction between a base and an acid to produce salt and water is called neutralization. Acid plus base give salt plus water is the general representation of this particular change. We have two examples here. In first case, copper 2 oxide reacts with sulfuric acid to give copper 2 sulfate plus water. Here the metal oxide acts as a base. The formula equation is CuO plus H2SO4 gives CuSO4 plus H2O. Second example is sodium hydroxide plus hydrochloric acid gives sodium chloride and water. Formula equation is HCl plus NaOH gives NaCl plus H2O. Here, sodium hydroxide is the base. According to the acid, the salts are formed, which are sulfate salt in case of sulfuric acid and chloride salt in case of hydrochloric acid. The name of the salt has two parts. The first part is obtained from the base. The second part is obtained from the acid. Further, we can see a few more examples where acid react with metal oxide to give the salt, water, along with the release of heat also. Here, hydrochloric acid reacts with calcium oxide, gives calcium chloride, water molecule, and heat. Formula equation is HCl plus CaO gives CaCl2 plus H2O plus delta. Delta is the symbolic representation to heat. As the formula equation is not balanced with more chlorine and hydrogen atoms in the product side, therefore we do multiply 2 and write the coefficient 2 to balance the equation. We can add and write the condition and states of the reaction also to make the change more informative in the chemical equation. Hence, we do write AQ for aqueous for hydrochloric acid, which is in the diluted form, S for calcium oxide in the solid state, which gives salt dissolved in water, aqueous, along with water, liquid in state, and as heat is released, the change is exothermic. Sulfuric acid reacts with sodium hydroxide, gives sodium sulfate along with water and heat. H2SO4 plus 2NaOH gives Na2SO4 plus 2H2O plus delta. Again, heat release and the change is exothermic. The two added in the reactant as well as in product side to sodium hydroxide and water molecule respectively is to balance the chemical equation. The next example is hydrochloric acid reacts with potassium hydroxide to give potassium chloride plus water plus heat. HCl plus KOH gives KCl plus H2O plus delta. As the equation is balanced and complete, so we need not to write any coefficient or balance for balancing the equation. Third, this chemical property of acid gives the idea of formation of salt water and carbon dioxide gas when an acid reacts with carbonate or bicarbonate, hydrogen carbonate. Acid plus metal carbonate, metal bicarbonate gives salt water and carbon dioxide. Example, magnesium carbonate plus hydrochloric acid gives magnesium chloride plus water and carbon dioxide. The formula equation is MgCO3 plus HCl gives MgCl2 plus H2O plus CO2. Coefficient 2 is added in the reactant side to hydrochloric acid to balance the equation. Carbonate, when reacts with acid, release carbon dioxide gas, which when passes through the lime water makes it milky. The excess of release of carbon dioxide not only turns lime water milky but forms a white precipitate in it. When an acid reacts with metal carbonate or metal bicarbonate, hydrogen carbonate, then a salt, carbon dioxide, and water are formed. We can have another example of sodium carbonate, which reacts with hydrochloric acid to give sodium chloride, carbon dioxide gas, and water. Na2CO3 plus HCl gives NaCl plus CO2 plus H2O. 2 is added to balance the equation to both reactant product side to hydrochloric acid and sodium chloride respectively. The physical state of the entities can be mentioned as S for sodium carbonate being solid in state, aqueous hydrochloric acid gives sodium chloride dissolved in water, aqueous, hydrogen gas is released, so G, and water molecule as liquid L. Sodium bicarbonate or sodium hydrogen carbonate similarly when reacts with the same acid, hydrochloric acid, gives sodium chloride, carbon dioxide gas, and water. NaHCO3 in solid state plus HCl aqueous in state gives NaCl aqueous in state, carbon dioxide as gas, H2O as liquid. When we consider this particular change, it can also be seen with the calcium carbonate. When the same happens, carbon dioxide gas release turns lime water milky. If someone is suffering from the problem of acidity after overeating due to excess of hydrochloric acid produced in stomach, we can suggest taking baking soda solution as a remedy. This is because baking soda is sodium hydrogen or bicarbonate which reacts with the excess acid, hydrochloric acid in the stomach and neutralizes it. This gives relief to the person suffering from acidity. Since in the change, carbon dioxide is released along with the salt and water formation, this is not at all the example of neutralization reaction. Acids have corrosive nature. The mineral acids cause severe burns on the skin and attack and eat up materials like cloth, wood, metal surfaces, and stonework. In order to warn people about the dangerous corrosive nature of mineral acids, basically hydrochloric acid, sulfuric acid, nitric acid, etc., a hazardous warning sign, which is in the picture, is usually printed on their containers. The sign tells people to be careful and protective while handling these. When we consider the chemical properties of acid, it can be explained as with ionization. When an acid dissolves in water, it undergoes ionization. Being ionic compound, it gives out cation and corresponding anion respectively in water. Cation is H plus ions or hydrogen ions, and the corresponding acid polyatomic ions are formed. The properties of an acid are due to the presence of these hydrogen ions. When we take up the example of citric acid in water, it releases hydrogen ions and citrate ion. Sulfuric acid in water gives hydrogen ion and sulfate ion. Hydrochloric acid in water gives hydrogen ion and chloride ion. Similarly, acetic acid gives hydrogen ion and acetate ion. Nitric acid gives hydrogen ion and nitrate ion, and corresponding ions simultaneously gives H plus ion or hydrogen ion, the cation in water along with the corresponding anion. When an acid dissolves in water, H plus ions formed and its concentration depends allows it to be in the strong category or in weak category. If complete ionization occur, then the acids are strong acid. When incomplete ionization occur, then the acids are weak acids. Mineral acids completely ionize and are strong acids. Organic acids incompletely or partially ionize and hence are the example of weak acids. Some uses of acids on the basis of the chemical properties. Hydrochloric acid as used in the cleaning metallic surfaces before they are painted or coated with other metals. Sulfuric acid used as an in car batteries making fertilizers and plastics. Nitric acid making fertilizers and explosive. Ethanoic acid preserving food and in cooking. Citric acid making health salts. So today we discussed the chemical properties of acids, which says that acids react with active metal to give hydrogen gas along with the formation of salt. Acids react with metal carbonate and metal hydrogen carbonate to give carbon dioxide along with the salt and water formation. Acids react with base to give salt and water, and this reaction is called neutralization reaction. Bases could be hydroxides or metal oxides. Acids react with metal oxides to give salt and water. Thus, we are concluding with the chemical properties of acids. In our next class, we'll start with chemical properties of bases.